Okay, so AES-128, what is it? Basically, it's an encryption algorithm. It's like one of the more secure ones out there. And how it works is that it's a block cipher. So a block cipher pretty much means that you have your cute little plain text. Maybe it's I love your mom or something, and you want to send that to your enemy's mom, and obviously your enemy doesn't want to, you don't want your enemy to know that, so you encrypt it using AES. And basically, with it being a block cipher, that means that your plain text is also broken up into chunks or blocks of 128 bits. In other words, it is also broken up into 4x4 blocks of bytes. So this is like a 2D array of 4 bytes, 4 columns, and 4 rows, and you have a multiple of these to represent your entire plain text. And guess what? You also have your key, which is coincidentally also 128 bits. And well, if your plain text is being broken up into 128 bits or 16 bytes, you don't want your key to also be 16 bytes. But you need to encrypt all of your plain text. So what we do is we put the key through a key scheduling algorithm, and what this does is it creates multiple subkeys, which we will call a round key because it goes through multiple rounds of transformation. Each block goes into multiple rounds of transformation. So we use our first key, second key, third key, and so on. And it actually goes through 10 rounds of transformations. So let's look at that. Let's look at the transformations in a bit more detail. So we have our plain text block, our state, whatever you want to call it. Well, maybe not our state because it's the state is going to be the state of our internal state of our plain text as we're transforming it. And then we're going to have our key, and as I mentioned, it goes through a key scheduling algorithm so that we get all keys for every round, all of our 9 remaining rounds, because the first round is going to be it's going to be from our original key, right? So then that goes into a multiplexer, which goes into our black box key scheduling algorithm, and then that's gonna go into a demultiplexer, and one of those outputs is going to go feed back into the multiplexer, and that's how we get all of our 9 keys. So that's gonna be like 9 rounds of key scheduling. And also we have the plain text. Now that we have our keys, we can add our first key to the plain text. So that's going to come from here. It's going to go in there, and that's just an XOR function. We'll call that add round key, or we just add key, right? And then this is going to go into a multiplexer because this is also going to be our transformation. Our first transformation, that's going to be subbytes. And what subbytes? So, well, subbytes is simply a substitution of our bytes in the state for another byte using an S box, which is already predefined. And then what do we do next? We go to shift rows, and in our shift rows, we're shifting the first row of our plain text of our state array by 0, and then the next one we shift it by 1, and the next one by 2, and so on. And basically how we do that is through a sort of rewiring. So we have the input, and it just gets put into a different sort of output, so it sort of like shifts itself. And then our last row, our last step in this transformation is going to be mixed columns. And mixed columns is us multiplying each vector or each column of the state array by a predefined matrix, right? And then the result of that is, so that's going to be like the result of our state. And then after that, we add our key from our key schedule, the next one to that, add round key. And then that also goes into the demultiplexer. Again, one of the outputs, it's going to go back to the beginning where we do the rest of the 9 rounds. And then, well, this is starting to get a little cramped, so I'm going to move this a bit up here. And then after this, right, for our last round, we have subbytes, again, subbytes. And then we have shift rows, so the rewiring. But the difference with the last round is that we don't actually mix columns anymore because it doesn't really add much to the security of AES, so we can leave that out. And then the neat thing, again, we add our round key, our last round key, add round key. This is getting a bit garbled, but hopefully you understand. And then we get our ciphertext. And then our key schedule, all right. Forgot to mention, got to add just this little bit, is that last key comes from there. And that's pretty much how it goes, so yeah.